Many people think that pennies are boring, but in fact they are very interesting. For example, did you know that on a penny Lincoln faces to the right, whereas on all other coins, whoever is on it faces left? See, I told you pennies were interesting. For our penny lab, we decided to roll pennies down a ramp to see how far they would roll and which direction they would fall when they were done rolling. In order to reproduce this experiment, you need a couple of materials that you can easily find. First, you need a $200 Introduction to Analysis 2nd edition textbook. Second, you need a Teen Vogue binder from Staples with the pink flowers on it. Next, you need a measuring tape. Last, you need 50 pennies. This setup is very complicated. Take the binder and put it on the edge of the textbook to make a ramp.
The first plot shows the distribution of the years that pennies were made. It can be seen that out of 50 pennies, most of them were newer and others were from late 1950s to 1990s. Next, we have a plot that shows the different kinds of backsides of the pennies we had. The bar that is not labeled is a penny with a man sitting on a log looking lonely. This plot shows how many pennies rolled to the left and how many pennies rolled to the right. More than twice as many pennies rolled to the left rather than to the right. This is most likely due to some error since we would expect half and half. Here we have a scatter plot with the year of the penny versus distance. It seems somewhat random but also may have a positive trend. Similarly, we have a scatter plot of the distance that coin travel versus the time taken. Again, this looks a little random but could also have a slight positive trend. Now we have a distribution of the distance the pennies rolled. It can be seen that the distance of the pennies has a fairly normal distribution with a slightly skew to the right. Again, we have a histogram distribution of the time the pennies rolled. The distribution is also approximately normal but with a slight right skew. It is slightly odd that skews of the distance and time are opposite, but this is most likely due to the fact that some of the pennies that roll longer ended up turning and rolling backwards. This means that the distance becomes less and the time ends up being longer. Last but not least, we have a correlation plot of all the variables. This shows how each of the variables are related to each other. In this plot, the color represents positive or negative correlation, with the blue being positive and red being negative. The size and darkness of a circle represents how strongly correlated the variables are with each other. In the lower left, the actual values of the correlation are also given in color and darkness.
Our experiment was obviously perfect and there was no errors with dropping the pennies or the floor being not flat. Now even you can have tons of fun and be as cool as us by rolling pennies down a ramp.